uh, figure 2 show the two charge Q1 and Q2 separate by the 4 cm apart. So this is a Q1 and the Q2 this distant 4 cm, and we have a point P here, distant 3 cm. So meaning if you find the direction, the distance, use Pythagoras. So you have this is 5 cm, right? So this is angle theta. So now the first question is, so the first question asks you to sketch electric field due to Q1 and the Q2, meaning at the point P here you have the 2E electric field E at the point P is produced by the at the point P you have an electric field produced by the E, because of E of the charge Q1, let's say this is E1, and produce E by the charge Q2. So what is direction? Let's sketch electric field due to the charge Q1 and the Q2. So at the point P here, because this is positive, Q1 is positive charge and Q2 also positive charge. So meaning the direction of the electric field for the positive and negative charge is outward. And the same, this is positive, the direction electric field here is a positive charge. Meaning at the point P you have the first is E1. So the E1 for the charge Q1 direction is upward. So meaning at the point P you have a E upward. So this is electric field E1 because of charge Q1. And we have another E for the charge Q2 direction like this. This is E2. Or if you draw the separate diagram, so now you have a E1 to, sorry, so you have a point P and direction of the E1 on the y-axis is upward, and you have another E is to the left here. This is E2, right? So this is a electric field at the point P because of charge Q2 and Q1. And number 2, this means the resultant. So meaning at the point P here you have two electric, you have E1 and E2 at the point P, and the next you must, to calculate the resultant, you must resolve E1 and E2 to the x-axis. So resolve E2 to the x, let's say you have a E2x, and resolve E2 to the y-axis here. So here we have a E2y, and for the E1, because E1 on the y-axis, meaning this is a E1y. No need for you to resolve E1 to the x. So this is x-axis. But you must know the angle here, theta. So you can use, if you look at the diagram here, right? To calculate the angle here, let's say the theta here, so you can use the triangle here. Let's say you have use a tangent theta, right? Tangent theta is equal to 3/4. 3/4. So meaning that you can find the value of theta or angle is equal to, the angle here is a 36.8 degree, right? So the angle here, is a 36.8 degree. And the next, you can find the value of the E1 and E2. So meaning, what is the value of the, this is E2, and what is the value of the E1? To calculate the value of the E1, you can use the equation, electric field equation, KQ over R square. and the value of the k is constant. This is 9 exponent 9, and the q default E1 is equal to q1 is equal to 3.2 exponent minus 6, and the r squared, the distance q1 to the point P is 3, convert to the meter is 3 exponent minus 2. So now if you calculate the value of the E1 is equal to 3.2 exponent 7, right? And the same process for the E2. So the E2 is equal to same equation, k q2 over r square, and the k is a 9 exponent 9, q2 is a 4.8 exponent 6, and the r distance from the q2 to the E1 is equal to 5 cm or 5 exponent minus 2. You just use the value in the SI unit, and if you use calculator, you can calculate the E2 is equal to 1.73 exponent 7. So now you can find the value of the E1 and E2. So the next process, you must resolve E1, E2 to the y and the x. So the E1, E2, resolve to the y axis, resolve to the y. So the E2 is a 3.2 exponent 7. So resolve to the x-axis. This is e to x, sorry. Must use your cos. Theta is a 36.8. So this is equal to, so you can use the calculator here, your calculation, right? Or you can use the e to y is equal to, E2 is equal to 3.7 exponent 7, but resolve E2 to the y is equal to sine angle theta. Angle theta here is a 36.8 degree. So you can use the calculator to find that E to x is to y, and E1y, this is just for E1y, because totally on the y-axis, just y, resolve to the y. So E1y is equal to 3.2. This is 3.2. Sorry, we have the mistake here. E2 is 173, right? Sorry, so this is the correct value, because e to x is E2 is 173 exponent 7, but resolve to the x, so E2 resolve to the x, so must use a cos 36.8. You can find the value of the E2x. So the same process, E2y, opposite, so we have a sine 36.8, and E12, because this is on the y-axis, no need for you to resolve to the x. Just E1 just have a y-axis 3.2 exponent 7. Okay, so this is 3.2 exponent 7, and the last process, you can find the resultant at the point P because of E1 and E2. So you find the value of resultant, or E at the point P, is equal to square root, right, EY square plus E x square. So meaning you can find the, this is for the E, this is for the E, total for the E y, and this is total for the E, this is for EX, this is for the EY. But make sure for the E to X, this is a E to X direction to the left, so meaning you must have a negative sign here, and the E to Y to the upward, so meaning this is a positive, and the same for the E1Y is to the upward, so this is a positive, positive, but e to y negative because direction e to x to the left. And you can use the equation here, so you can find the value of the resultant e at the point P. So you can find the value, the answer is 4.46 exponent 7. And the angle here, and the angle here 1 to 8, so you can use the equation tangent theta is equal to EY divided by EX. So we need EY and the EX. You can find the theta here, and this is the answer 108 degree, right? And the next question is calculate electrical potential. So as you know, electrical potential V equation is Q over R. But now at the point P here, potential at the point P is must refer to the, because of Q1 and the Q2. So at the distance here, 5 cm from Q2 and 3 cm from the Q1, at the P we have two potential, meaning this is total potential is at the P total potential Q1 and Q2. So meaning at the point P potential we have a K Q1 over R1 plus K potential by the Q2, and this is R2, this is 5 cm. So K is a constant, 9 exponent 9 says constant, and the Q1 is a 3.2 negative 9, sorry, Q1, Q2 4.8 exponent minus 6, and R1 is a distance Q1 to the point P is a 3, is in meter is minus 2, and the R2 is a distance VP to the Q2, so this is 5 exponent minus 2, and the final answer, potential at the point P is equal to 1.82 exponent 6 volt. And the next is a B. This means the work done in moving charge along the equipotential line. Explain your answer. Right? So the answer, the work done is 0. Why? So if you use the word equation, work done to bring charge is a charge Q time delta V. But the charge along the equipotential line, equipotential line meaning the V is the same value. Let's say you have a V1 is equal to a volt, and V2 have a same value of the potential A. So meaning the change of the potential delta V is a V1, okay, minus V2, but the value of the V1 is equal to V2, meaning delta V is equal to 0. When it's 0 times Q, so that's why work done is equal to 0. Thank you.